AI agents have evolved from basic chatbots into background workers that can run your calendar, execute code, and manage workflows autonomously. But if you try to build one today, you'll likely hit a wall. Most people spend a weekend wrestling with massive frameworks, Docker containers, and API keys, only to give up before the agent actually does any work. The ecosystem is currently dominated by monolithic frameworks. They try to be the single solution for every possible use case, from basic WhatsApp messaging to complex browser automation, all at once. That approach creates a harsh reality for developers. You are forced to balance the control you want over your infrastructure against the friction you are willing to endure to set it up. Think of it like a grid. On the x-axis, infrastructure control and local privacy. On the y-axis, setup friction. Maximum security and zero setup time do not overlap. The architecture you pick right now will dictate exactly where your vulnerabilities lie and what your server bill looks like at the end of the month. Choosing an agent framework is an exercise in identifying which specific compromises your business can survive. Let's start with the path of least resistance, zero-friction cloud options, like MaxClaw and Space Agents. With these, you aren't installing anything. You rely entirely on third-party pre-hosted interfaces. You describe the workflow you want, hit deploy, and have a fully functional multi-step agent running in under 10 seconds without writing a single line of code. The trade-off is total surrender of data sovereignty to the host and strict lock-in to their chosen models, like Miniax M2.5. On the direct opposite end of the spectrum is the heavyweight monolith. OpenClaw is the perfect prime example. To run it, provision a VPS, configure your Docker containers, and deploy 400,000 lines of code. That complexity grants you immediate access to over 5,000 community-built skills and native integrations for 11 different messaging platforms. The cost is heavy resource consumption. OpenClaw needs over 1.5 gigabytes of RAM just to idle. Because it allows default shell access to run community tools, you expose an attack surface that is notoriously difficult to audit. These two extremes force a strict binary. You accept convenience that exposes your data, or you take control but rapidly drain your hardware resources. If you want control without the bloat, look at minimalist alternatives like ZeroClaw and PicoClaw. This chart shows the massive gap in resource demands. These strip away the Node.js runtime entirely, compiled as single binary frameworks built from the ground up in Rust or Go. That architecture drops memory usage under 5 megabytes and cuts startup time under 10 milliseconds. You can run these agents on a $10 edge device like a Raspberry Pi. The trade-off here is isolation. Developers have to manually build their own integrations, sacrificing the massive plug-and-play community ecosystem. If your priority is data safety over hardware efficiency, you move to security-first frameworks like IronClaw and NanoClaw, built for enterprise deployments. These frameworks implement strict WebAssembly sandboxing and OS-level container isolation for every single session, neutralizing prompt injection attacks. If a malicious instruction tries to exfiltrate your API keys, the sandbox physically prevents it from accessing the host file system. Zero trust means zero shortcuts. Development speed crawls to a halt because every single new tool requires you to manually configure strict capability-based permissions. High efficiency and true zero-trust security are achievable, but you only get them by actively sacrificing your ability to iterate quickly. Once you solve the hardware constraints, you have to manage how your agent behaves over hundreds of tasks. This is where self-evolving layers like OpenSpace come in. OpenSpace plugs into your existing framework and analyzes past failures. When a skill breaks, the agent autonomously rewrites its own instructions to fix the error for the next run. This chart shows the economic impact. By reusing successful logic, you see a compounding 46% reduction in LLM token usage. But trusting a system to alter its own code introduces unpredictable behavioral drift. The agent's logic can wander away from your original intent. The alternative to self-evolution is rigid, hard-coded alignment, similar to the 80-page constitution Anthropic uses to govern Claude. Strict foundational alignment creates overly paternalistic agents. They may refuse completely legitimate operator commands out of an abundance of caution, forcing you to build complex workarounds. Managing an agent long-term means choosing between the efficiency of unpredictable self-optimization or the friction of highly restrictive safety guardrails. You have to stop blindly deploying OpenClaw just because it's popular, especially if you lack the server budget or the in-house security expertise to manage it. We can map out the correct framework based strictly on your technical constraints, starting with one simple question: do you know how to code? If you are non-technical or simply don't have the time to manage servers, your answer is Space Agents or MaxClaw. You trade data privacy for speed, but you solve your automation problem today for free. If you do have engineering resources, you split into two camps based on your risk tolerance. If you need bare metal cost savings at the edge, pit it to ZeroClaw. If you are handling sensitive enterprise data and need isolation, you deploy IronClaw. Finally, for the operators looking to scale these workflows and pet API costs over the long run, you layer OpenSpace onto your chosen framework to reclaim token margins on your complex, repetitive tasks. An AI agent's intelligence is strictly bounded by the infrastructure it runs on. You must choose your constraints before they choose you.